high school geometry angles and triangles and stuff. First read the prompt. An equilateral triangle and an isosceles triangle. Alright, let's define some terms real quick. So this is the equilateral angle because these three sides are all the same. And they're shared by a common side. Okay, so now this side length, all of these side lengths are the same. Whatever it is. And all of these angles are 60 degrees because the total is of an area angle of a triangle is 180 degrees. Okay, and if they're all the same, equilateral, they mean the exact same thing. Equiangular and equilateral triangle both mean three sides with three angles and three sides that are equal. And so if we want to find each of the angles, we say, let's say the angle be x, and at later high school courses you'll have a thing that looks like a zero with a line through it called theta. But we're just going to use x for now. And there's three angles, so 3x. Now, to solve for x, you just divide both sides by 3, leaving 60 per angle. So we have 60 degrees for this angle right here, this one, and this one. Now, find the measure of A, B, C. Well, we know this angle right here is 67 degrees, but we don't know it's equal to this one because it's obviously not, because this angle right here is 60. But 67, these two lines are equal, and the base of an isosceles triangle. So if I draw a triangle, this is going to be really bad. Yeah, this is really bad. But if the triangle has these little marks like this, they're the same. Okay? I know that's a really bad triangle, but those two are the same. And so we could say if it has these two circular marks right here, or this two marks right here, you could say that is an isosceles triangle because two sides are equal and it isolates one side that is not the same. This side is isolated. But these two angles are the same. So this angle A right here is the same thing as this angle right here. So this is 67. And so we can solve for this angle B that's on this isosceles triangle by doing 180 minus 2 times 67. Alright, so 180 minus, minus this angle right here and this angle to solve for this angle, because there's 180 degrees in a triangle. So we're just trying to solve for the remaining side, and if we know those two are 67, and 67, then we can confidently say that this angle B right here on this isosceles triangle is 46 degrees. So this is 46. But we want the angle ABC, and A and B is the middle point. So here we start at A, and then we go to B, and then we go to C. But that only encompasses this triangle. What about this triangle? Well, we know that this angle right here is 60, like all the angles in the equilateral triangle. So we take angle ABD, and then we add it to DBC, and so we get, which is the same thing as saying 46 plus 60, this angle right here plus this angle right here, and 46 plus 60 is 106. So therefore angle ABC is 106. Alright, let's do another one. So we have these three angles right here, and here's a couple of things that we know about this. This is a triangle, but we see these two hash marks right here, which are saying, hey, these two sides are equal, and they point at the same base. So the corners that are next to those, this and this corner, are equal. So what we could set up an equation to look like is x plus 17 is equal to 4x minus 34. And how I deduce that is because this and this mean that these two sides are equal on a triangle, and if that is and they are connected to the exact same base, and so the angles that they create are the exact same. So x plus 17 is this angle, and the other angle is 4x minus 34, so you can set them equal to each other. And this angle here in this situation, you could say is just not necessary, but if it asks you in like part B or something to say what is 6x plus 10, you can multiply x by 6 and then add 10. Alright, so let's solve this thing. So we have 4x minus 34, so let's add 34 to both sides because there's a negative 34. So 17 plus 34 is 51. So we have x plus 51 equals 4x. Alright? And then we have x's on both sides, so we need to subtract an x from this left side right here. So if we subtract x from both sides, we have 51 equals 3x. And so now what we would want to do to solve for x is this 3 is multiplied by x. So we're going to do the exact opposite. You do the exact opposite of PEMDAS to solve for x. So we're going to divide by 3, and 51 over 3 is 17. So you divide by 3 by both sides, and you get 17 equals x. So if I would have put 17 in here, I would have gotten that question correct. Alright, so an equilateral triangle. I find it useful to draw a picture, or if you can't envision it in your head very well. So this is going to be a very bad picture, but we're going to have the hash marks and to say that all the sides are equal. So equiangular means equilateral. Just keep that straight. They're the exact same thing. If something says equiangular, it's also equilateral. If something says equilateral, it's the same thing. So this is what it's going to look like. All the angles are the same. Oh, that's not what I meant to grab. And all the hash marks are the same. An equiangular triangle has one side length of 6 inches. So if we know this side is 6 inches, then this side is 6 inches, and so is this one. What is the height of the triangle drawn on a scale? To the 10th of an inch. Okay. So we need to solve for the height, and if we know that these two are 6, if we know each side is 6, but we'll only use 2, but you should know that all sides are equal to 6. Let's get a different color. Let's grab a green. So we're going to solve for this height, and we'll set the height equal to x. And so we're going to use something called Pythagorean's theorem. Okay, and so if you have learned this in algebra or even your geometry class, it's a little bit confusing to explain. If you want me to do a proof of this later, I can. But so 6, if it's the height, it's going through the top of from the base to the top. So even though it doesn't look like it, 6 is going to be cut in half because this is exactly in the middle, because it's from the height is the middle point to the bottom. So 3. And so I'll write out the formula first. And so we have side lengths of A and b is the height, so a and b, a squared plus b squared, b squared, and so that's going to equal this side squared, c squared. So now we're going to shove in values for this and solve. Alright, so now we remember the formula. So let's solve in values. So let's say a is this bottom side, but we only want half of it because the height only goes to the middle. So we got 3, and then you square it, and then plus, we don't know the height, so let's just leave it as b squared. Okay, and then we know the right side, we know the diagonal of the, and that's what this is solving for, is the diagonal. And so we know c squared is actually, we know c is 6. So now, if we simplify this equation, we get 9 plus some value. So I'm going to just, again, you could just say some value, just remember to take the square root of it. So I'm going to put the squared, and I'm just changing the variable name. I would not recommend doing that, so I'll keep it at b squared actually. And then 6 squared is 36. So now we can subtract like this is an algebra equation. So 36 minus 9 is 27. So if we subtract 9 from both sides, we get b squared equals 27. And if you guys don't know your perfect squares, you would know this is not actually a perfect square. So pull out your handy dandy calculator and just take the square root of it. And so b is not exactly equal to, but it says to the nearest tenth of an inch. So you got b, or the height. So I'm just going to say height because that's what it really is. I'm just using the Pythagorean theorem, is 5 point, I'm going to do the first couple of them, 5.196. Okay, and then nearest tenth of an inch. Well, this is the tenths place, this one, but because there's these other numbers, it's a 5.2. So if I put 5.2, that would be correct. Last one, but this is a little bit easier to give you a break, and maybe we should have even started with this one. So we got 57 and 2 unknown angles, and we want to solve for angle A. And there would be a drop down box, but we're not going to use it. We're going to use math to not even have to use the multiple choice. Okay, so we got A, B. Well, we know this is an isosceles triangle because these two hash marks, and they're pointing to the same base and which angles are connected. We got B and C, so angles B and C are automatically the exact same angle. So in case you forget, if this is on a piece of paper, or just write it down on your scratch sheet, angle B and C are both equal to 57. Do you want to know what you can do now? You can solve this just like an algebra equation. The sum of angles are 180 degrees. Always. The interior angles of a triangle. Inside the triangle, this angle, and this angle will always be 180 degrees if you're on a flat sheet of paper or on a computer screen. So we know angle B is 57, and then you could subtract the other angle that you know, which is also 57. And so, and then you're going to so we have this equation, 180 equals 57 plus 57 plus the other value. Then you subtract 57 from 180 twice, so 180 minus 57 equals x, because we're just subtracting. isolating the unknown value. And the unknown value is, in this case, 66. So then this is 180 minus 57 is 66, and that's going to equal the unknown value. And so this unknown value right here is equal to 66 degrees.